All right, with this project, with replacing the first generation alternator with a third generation alternator, I have run into a little bit of a physical mounting challenge. There is a lower control arm bolt and arm that are used to help the alternator move toward or away from the engine so it loosens or tightens the drive belt. Well, the adjusting arm for the first generation alternator is set forward about a quarter inch too far for this alternator. So this recording is being done on a Sunday. All of our wrecking yards are closed, and I say wrecking yard because no parts store is going to have what I'm looking for in stock. What I have in mind is to go to a wrecking yard, find an older car, preferably an older Ford, and find one with an engine that still has the alternator mounting brackets on it. Take off the old mounting bracket that is used to adjust a belt tension and cut it short. And the part that has the adjusting slot, one end I can bolt to this adjusting arm and the other end can become an extension. And that way I can go ahead and move the alternator further away from the engine. And the way that the two mounting pieces will work is that the new one will stack on top of the old one, and it will give almost a quarter inch of the length or height that needs a difference than what we don't have available. Simply by bolting the two together like that, I can use one of these spacer shims to put down on the bolt or bolts that are holding the two adjusting arm pieces together. That way I can space the one that I'm attaching further away to get that distance that I need so that the extender piece will match where this alternator needs to be. So anyway, I think that'll work. Meantime, I don't want to slow the process here down, so today I'm going to get into rewiring the charging system circuit for the 3G alternator and cup. So what I would like to do today is show how we take this 3-wire plug that plugs into the 3G alternator and wire it so that it is correctly connected to the vehicle and to that special PA performance switch. Now I have done a quick modification to a wiring schematic, and I show the color coding of both the wires coming from this 3-wire plug and the wires on the vehicle. And I hope it's clear enough for everyone to see, and I will put a link in the description of this video, and the link will go to my Google Drive where you can see this document. And I think page 3 or page 4, it shows this wiring. Now, the other thing I'm going to do is not only follow the schematic that I laid out for that, but the output terminal of the alternator from the factory has a wire going from the old alternator's output terminal over to the starter relay on the positive battery connection, and it is black with an orange stripe. I'm pointing to mine right now. I don't know if you can see that, but I'll show you later. Now that leads all the way to the alternator, and that's a pretty good sized wire. It's pretty thick, but it would work fine for the first generation alternator, which at most would put out 65 or 70 amperes per hour of power. This 3G alternator, it comes in two different sizes. The smaller frame conventional 3G alternator will put out about 95 amps, so a little bit more than the original alternator. We have the slightly larger frame 3G alternator because what came out of this car was a larger frame 70 amp side terminal alternator. Well, this alternator puts out 130 to 135 amps, which is twice, almost twice, what the first generation alternator would put out. So it is possible, if we have enough demand on the electrical system, it's possible that this black and orange stripe fusible link wire that connects the alternator may not be enough to handle the load, and it could end up burning out, and then that would leave the alternator just kind of sitting there trying to produce power but having nowhere to send it, and the car would be dead. So what I did is, earlier in this video I showed that I had gotten a length of gray fusible link wire. I cut it in half, and on one end I put a relatively large I terminal on it, crimped it, and then I used the shrink wrap tubing to protect it. The other end, I had these two wires, and I put separate I terminals on them. And what I'm going to do is I'm going to put these on the 3G alternator's output post, along with the terminal for the black and orange wire from the factory. And the larger end I will connect to the battery post terminal on the starter relay. And it looks like I have quite a few things on here already, but it looks like I got enough links on the attaching terminal screw to put one more device on. So that I'll do very last. Now what I won't be doing today is I won't be able to do a test of the alternator and wiring when I'm done, because I need the bracket to adjust the arm. Oh, and I need another fan belt. The fan belt I have is going to be too small for where this alternator needs to be moved, so I'm going to measure how big that belt needs to be and compare it to the existing belt, and simply go to a parts store and have it match up. Okay, so the first thing I need to share about the schematic I'll be following is that there are colors that match up to this plug that connect to wires on the vehicle that do not. So what we have on this plug is 3 wires. One of them is green with a red stripe. And on my schematic, this connects to the orange wire with a light blue stripe, totally different color, and that is intentional. There's a yellow wire, and that ends up being connected to the battery itself, or electrically we can attach it to the alternator terminal, and it'll be an equivalent place to put it. The third wire is white with a black stripe, and it has an end terminal connector to it that plugs into the alternator for stator current. Now, in the case of a lot of the 1971, 72, and 73 cars with the original alternator, that white wire with the black stripe ends up powering the electric choke on the carburetor. If you have an aftermarket carburetor like we do, like a Holly, those electric chokes cannot use the stator circuit for power properly. It has to be a full 12 volts of switched power. The stator circuit, white with a black stripe, only outputs about 6 or 7 volts, and it's not direct current or DC. It is alternating current, AC, so it's unlike any other current anywhere else on the car. Now, in our case, I already have 12 volts of switched power going to electric choke. I put this connection on here in case I ever wanted to use stator circuit for something else. One thing it could be used for is to activate a relay, because the only time there's current is when the engine is running, not just switch turned on to run, but the engine actually has to be running where the alternator is putting out power. And that power is enough to cause a relay to go ahead and close its connection, allow something else to happen. So this is just something I'm going to do for future. If you have a factory carburetor with the electric choke, then you will want to do something like I did here and just simply put a butt-end connector on the 2 wires going into and out of the butt connector, and then plug this into the proper socket and the alternator, and I will show that in detail in a few more minutes later on in this video. So it's that easy, and what makes it that easy is using the PA Performance adapter that replaces the voltage regulator on this car. And just to reiterate, the voltage regulator for the alternator is built into the alternator, and I will show a picture of what that looks like for a few moments, and you can cut. Now, when we're done with all this wiring and connecting and stuff, I'm going to be using shrink wrap tubing to go ahead and cover that part of the terminal end that meets the wire to help make it weather resistant. Now, in our case, that's overkill because we only drive this car when it's good weather. But I know there are some folks that enjoy driving their cars, their vintage cars, anytime at all, including when it rains. That's fine. If water gets up under the hood, having the shrink wrap tubing around the terminal ends parts is going to help keep everything nice and dry. Now, another thing, I know that there will be some people that are going to say, don't use crimp connections, solder it. Okay, soldering will give it a very solid connection. I understand that. But if it's not done correctly, it's possible for solder to travel when it's hot and liquidy down inside the wire, inside the insulation a little bit, and over time, if there's any movement, it can cause the wire to fracture. Well, we don't want that, which is one of the reasons why I like using these shrink wrap tubes, and it's because it helps take any flexing of the wire and spread the load over a longer piece, making it less likely anything is going to fatigue and crack over time with movement. As far as crimping versus soldering, there's another gentleman who I enjoy following his channel. You might know him as Wrenching with Kenny. And he also happens to like crimping instead of soldering, and his thinking is very simple. Manufacturers don't solder with their wires. Why should I? The crimping works fine. In his case, he goes ahead and uses metal pieces to do the crimping without this plastic shell. He uses simply shrink wrap tubing. In my case, I don't mind using this plastic coated stuff. Crimp it, make sure it's holding, and then shrink wrap these ends first, and then use shrink wrap tubing to cover even more. So I have something to help offset flexing strain and stress. Well, that's an awful lot to say before I start getting down to work here. So now I get down to it. First, I'll prepare this yellow wire with an eyelet terminal that will then connect to the alternator output terminal along with the two outlet wire terminal ends for the fusible link cabling I made. Now when I'm done with all that, there's going to be a lot of wire left over, unused. It's going to be too long. It'll look bad, except I also have plastic conduit, and the idea is to take this plastic conduit and put all the wiring inside it so that visually you don't see wires laying around, and the wires are protected from chafing, especially if they're near anything metal. We don't need or want short circuits because of chafing. So I went ahead originally and put these wires around inside the conduit first, and figured I'd wrap it all up later. And then I changed my mind and took the conduit off and decided to put it back on after I have all the wiring done in place the way I want it. So to start, like I said, I'll do the yellow wire. I will select an eyelet of the appropriate size.
And you're going to need shrink wrap, right?
Yes, it's right there.
Can you reach it?
Yeah, I'll be able to reach you. Thank you. That's too big. These might be too small. I'll check. Yep, that's too small. You can go and cut for a moment. It's gonna take. Okay, I found an eyelet terminal that looks like it's going to work out just fine. Before I attach it, I'm going to take the eyelet ends and make sure it fits over the terminal in the alternator, and it does. So that makes me like in Goldilocks, the bear that one size was too big, the other one's too small, this one's just right. I got a Goldilocks terminal. Then I'll get my heat shrink tubing I'm going to use to finish off the connection. I'm going to put the tubing down the yellow wire a little ways. This already has a bit of insulation stripped off the ends. I'm going to take a little more off because that's not quite enough for what I want to do. I want to make absolutely sure it's making good electrical contact. Then I twist the wire. And then, as I put this terminal on, I twist it to follow the twisting pattern from when I twisted the wire itself. And I do that while I'm putting the terminal down onto the wire. Now, you won't be able to see it from where you are, but at the very end, inside this plastic cover, I can see the very tip of the wire inside the crimp area of the terminal. So I know the wire is in there securely. So now I crimp. And I'm going to crimp in the full length. And then I test it by pulling. If this is going to pull out, I want it to pull out now, or I'm still easily able to work on it and not later. I'd say about 1, 2, 3 times out of 10, I can either feel the wire moving inside the terminal or it slips out, even though it felt like I had a good crimp. I have learned over the years not to trust a crimp unless I really pull it significantly hard. And then this is translucent, so I can look through this plastic cover and I can see the very beginning of wire that I stripped the insulation away from. And considering how long the uninsulated part of the wire was I put inside here, it's in just about the right position. So I can either use the heat gun now and shrink wrap this and shrink wrap this and move on, or I can move on and shrink wrap these all at the same time. I think I'm going to go ahead and do the former. As I make these up, I will shrink wrap them just because someone's going to make a decision, so I just did. And you can cut. When I first had this garage finished off with the wall boarding and the lights, I also had installed an overhead reel for an extension plug and for a drop light. There are some folks that I know felt I was going a little over the top for a home garage, but neither I nor they realized how many cars we would end up having. I would be working on where I would need the light and the extension cord. And this is one of those times where my outlets, I have a lot of outlets in the garage, but none are close enough for me to easily work with a hot air gun without taking whatever I'm working on out near a workbench, which is not practical sometimes. This is one of those times. Anyway, these wires I'll move out of the way. This one, I'll put the shrink wrap tube way away from where the heat is going to be. And now I'm going to heat this up and have this translucent red insulation shrink around the terminal. Let it heat up a little bit. And here we go. I have to be careful where I put this tip when I put this back down. I don't want it touching anything because it's really hot. As is where I shrunk this down. Now, in the earlier part of this video, I showed how this shrinks down, how it looked before and after, so I'm not going to bother doing that now. But now I'm going to move the shrink wrap tube up into place. And I'm going to hold it in place with my fingers on the wire and hit this now with the heat gun. I know I mentioned before in this video that some of the properties of this heat shrink tubing is that this is what they call a 1:5 shrink ratio. The tubing will shrink to 1/5 of its original diameter. And the other is that this is a marine grade shrink wrap tubing. Some shrink wrap tubing is just the plastic tube, and that's it. Marine grade, they have inside the tube a layer of adhesive that will melt when it's heated up. And so when it heats up and shrinks down, it has adhesive that will coat the wire and wherever else it covers with the adhesive. And when it cools off, it's now waterproof. Water cannot get into here. And I have coated a little bit on the terminal beyond where the crimp is, as well as way behind. So both ends are waterproof. And I know that's overkill for what I'm working on. I don't have to make it waterproof because we're going to drive in the rain. But you know, I'd rather go a little bit further than not far enough. And because there are going to be some folks that see this video that do drive when it's wet outside, I want to show how we can better protect our circuitry. Now, the white with black stripe, the stator circuit, is nothing more than me plugging into the third generation alternator a special plug where this goes. It's already there. This end I'm not going to use right away. So there's nothing for me to do with this. Now this end, green wire with a red stripe. I'm going to go and strip off a little more insulation like I did with the alternator wire. And at the other, on the one end, I'm going to put a butt end connector, a lot like this red one. The other end will end up going into a wire that carries 12 volts or battery voltage only when the ignition key is turned on. And there are two places where you can easily find 12 volts of switch power under the hood of a 1971, 72, or 73 Mustang. I have a separate video, I will put a link in, that gets into that in a bit more detail. In this video, I'm going to simply describe it and tell why I'm going to use the one and not the other. The first such power source is circuit number 540. It uses a wire that comes out of the firewall that is red with yellow hash marks, not a stripe, but hash marks. And normally that wire is used to feed the throttle position solenoid. And that is always a good place to pick up 12 volts from, as long as you don't need more than, say, 10 amps. And this is not going to take 10 amps, I can tell you that. The other place is to use the windshield wiper motor power circuit. And that's either circuit number 63 or 64, one or the other. And it is a red wire that goes to the windshield wiper motor. And that is a good place to pick up power from also. And in my case, that is where I am going to pick up my power, but not for the reasons that you might think. When the previous owner replaced the engine in this Mustang, he put in a high-performance engine and has a Holley 4-barrel carburetor, and it needed 12 volts to the electric choke. Well, when they put this in, somebody moved or cut the red wire with the yellow hash marks. I haven't been able to find it anywhere. But I needed to get 12 volts of switch power for the electric fans of this engine. So I have already tapped into the windshield wiper motor circuit 6364 and have the switch power coming out here. I've just got to find where I put it. I think I know where it is. I'll find out. Once I find out, I will splice this wire into that circuit. And I can do that because these fans, they don't take a whole lot of power for that switch power to activate the relay. That's all it's for, is I take that fan, that wiper switch power, feed it into a thermostat. That thermostat only turns on when the engine gets up to 200 degrees. It closes the thermostat switch, sends the power to a relay, and the relay then causes a high amperage current to flow to the fans. So I'm using it for a very low amperage purpose. This might carry as much as 5 amps, usually 2 to 3 amps. That's about it. So I'm not going to be putting a huge load on that wire, and that's why I don't mind extending the use of it. Now, in your vehicle you're working on, you're going to need to decide which of those two options you want, or you could, not to confuse things, but you could do something else, and it would be appropriate. If you know how to set up a relay, you can use the stator current to trigger the relay and then have that relay bring battery power to this green and orange wire. And that would be perfectly adequate. In my case, that would be unnecessary because I already have so much done with the 12 volt of switch power being available. So I'm going to move things off to the side, and then I'm going to see if I can find my power from the windshield wiper motor and bring it over to where I need it and splice it into that green and red wire. And you cut for a moment. Okay, I found the trigger wire I'm going to use, but I want to show on video how I tested to make sure that this has power. So what I'm going to do, well, the way I tested, I used a test light. I put the battery terminal for negative back on. I had the test light tip uncovered and touched it to a wire after pushing into the insulation to make sure there's no current. Then I had Linda put the car in run position for ignition switch, test it again, it had power. So that way I know it switched power. What I'm going to do is I'm going to cut away at these retaining straps for the plastic conduit to give me room to work, and I'm going to re-splice or splice into this wire so I can pick up the power I need to provide power to the alternator circuitry. So Linda found some small cutters I'm going to use to cut the old wire tie off. Might be nice if I had the light. This stuff is so hard to see, even with light on it. And these wire ties are really tough sometimes to cut through, which is a good thing. I want my wiring protected. Okay, got one off. And peel that away. And I can see my earlier butt end connector where I use this power for a relay that controls the electronic ignition module. I don't want to do anything to disrupt the work I've already done on here, because I know it's working well. So what I'm going to do is go down to the same wire a little further and cut and strip it, and then use that to tie my circuits together. And before I do that, I want to demonstrate how I tested this. So I turned this light off so it doesn't interfere with what I'm trying to show you. This is the negative battery cable. I put it back on the battery temporarily. I have my ground clip for my test light connected to ground. I take off the safety cover from the tip of the test light and I touch it to a wired surface, and you see there's no light coming on, so there's no circuit. So I will have Linda stop the video, put the car in run position, and then restart the video, and I'll show you how it looks. This light down to the same wire as before. And you see how it turned on? There's power there now. I'm going to keep holding it in the same spot and have Linda now turn off the ignition switch, and you'll see that the light goes out without me moving.
There, I got you on.
Oh, good. That's clever. Okay, so now I have re-verified this is a 12-volt switch power. Now, I have a voltmeter on an LED panel inside this test light. And so earlier when I had done this, I looked and saw it was battery voltage. So I know I am on a good connection for what I've got to do. So now, I'll unclip the test light, take that negative battery cable off and put it somewhere safe out of the way. And then I'll go ahead and cut into that power wire in an area that will leave me a lot of room to work as I splice other wires together. I don't want to cut myself short. So right about in the middle of this area of exposure, I cut. Strip both ends. And then I select the connector I want to use. And in this case, I'm going to use a blue instead of red butt-end connector, which will handle a bit more diameter wire than the red butt-end connectors. It's going to be big enough for where I thread two of these things together, but it's going to be bigger than I need for a single wire, but I can still make it work by crimping it really hard. Then I'm going to get my shrink wrap tubing for each segment that I'm going to be working with. I learned a long time ago that when I open up these plastic cases, it's best to make sure I'm on a good solid surface when I open it, and when I'm done, I close it and latch it. And that's because more than once I've knocked one of these things over accidentally with the lid non-secured, and boy, did I have a mess then to clean up, trying to get all the pieces, pick them all up, and put them all back into their special compartments. I learned over the years to avoid that by being a bit more careful and slowing down a little bit. So what I'm going to do here is take the 3-wire terminal that plugs into the 3G alternator, and the green wire with the red stripe I've already stripped and twisted, and I'm going to come over to either one of these red wires that I've stripped, and I'm going to twist it.
Do you want your stuff on it beforehand, your shrink wrap?
Not yet.
Okay.
Oh, yes. Thank you. Got ahead of myself. Shrink wrap tube. Linda saved me from embarrassment. Put that down there. Put another one down on the other wire. I gotta think for a second here. Yeah, that's fine. Take these two wires, twist them together as tight as I can. Then I take my blue butt end connector, and as I'm pushing the wire into the barrel, I twist to make sure that I get down as far as I can, and then I crimp, and then I crimp again a little further up the connector. Then I crimp one more time to make sure it's nice and tight, and then I try pulling, and it won't pull, so I'm in a good spot there. Now, for the other end, don't forget the shrink wrap tube. I send the shrink wrap down the wire, take this end and twist it, and then push it into the butt end connector barrel. And when it's in place, I go ahead and crimp it. And then I crimp again. Crimp again. And this one I will make sure is really, really tight because there's only one wire going into it, so I have to make sure I have crimped it as much as it can possibly be crimped. And then I pull on it, and it is holding real good. So now what I'm going to do,
You should have put those two wires into that shrink wrap, right?
well, there's only so much I can do there.
Yeah.
You know,
If you put them both in, you would have been able to connect.
I'm going to.
Yeah.
There you go. Okay. I'm going to keep this on the recording. Linda had a better idea than me. It means I got to redo something, but it is a good enough idea to make it worthwhile. These two shrink wrap tubes I put down here aren't going to do a whole lot of good because they both come up to the same location on this butt end connector. What I really should have done is before I connected this, I should have taken a larger shrink wrap tube and put it down here so I could then use it up a little higher. But it's a little too late now, so embarrassingly enough, I've got to redo this connection. I'm going to try to do it without having to cut these wires any shorter than they are. So I'm going to try to squeeze these connectors that were crimped crosswise so that the crimp opens up. And frees up the wiring inside. If I'm lucky, I can do that. If I'm not so lucky, Well, I'll have to recut the wire and just work with something a little shorter than I otherwise would have. My own fault. Let's see if that's far enough. Nope. Well, I already crimped that good, didn't I? So what I did, I went ahead and cut this power wire, and I'm going to go ahead and strip it. Both of them. Now, I use spade terminal for that, so I can disconnect it if I ever had to. I forgot. That's why I looked at it carefully and realized what happened. Did it on purpose. So it turns out that long ago, when I first put this splice together, taking power from the windshield wiper circuit, I had used a spade terminal and a spade terminal socket to make that connection. So if later I had to take it apart to test it or something, I could simply unplug it. Well, I forgot. So while I was stripping this wire, this pulled out, and I thought, oh no, I found a bad splice a long time ago, or a bad crimp. Nope, good crimp. It's just this wasn't set up quite right. It's pretty short, and I forgot about this. So now what I've got to do is put my butt end connector on here, shrink wrap tube it down, and that is the one connection, and the other end I will twist this green or red wire in with this other red wire, put that into this butt end connector, shrink wrap it down, and then put the tubular shrink wrap, and we're done. Oh, after I plug this back in, and then I put it all back inside the conduit to hide it. Now, I know that I had stripped this insulation of the green and red wire earlier, but I had a little bit of a planning disruption that Linda found, and so I'm going to do it again, because I had to redo a whole section of this video, because she saw something I didn't. This is shrink wrap tubing a little bit bigger than what I have elsewhere. So I'm going to send that down. These two wires that I'll be putting together. Way back out of the way. So when I use a heat gun for the butt end connector, it won't cause it to shrink down, or I don't want it to be shrunk. Now I take these two wires, the orange versus light blue, the red from my switch power, and the green with red stripe from the 3-wire plug, and I twist them together as tight as I can. Then I add this one and twist again.
You're not going to use a butt end?
Yeah, I am. I'll splice that part out.
I thought you were going to do the 2 in the one end and 1 in the other
Yeah,
end.
I am. There's
Okay.
a 2 there.
And then you sleeve
I lost
over
count.
it. Yeah.
Okay, so now I'm going to take my section that has the spade terminal splice and pause for a second if you would.
Go.
So the spade terminal section, I'm going to start by twisting the insulated area, putting that first butt end connector over it, and push it down into place, and then I crimp it. And I crimp again, and then since it's a small single wire and a butt end connector, it's a little bit bigger than it should be, and I'll crimp it really hard, and then check and make sure that it is a solid connection, and it is. Now for this one, I have my shrink wrap tubing at the ready. So once I heat this up and shrink down this section, I'll be able to slip this down, put the shrink wrap tube over the rest of the assembly, and shrink it down. Meantime, because this unplugs and plugs into the circuit, I'm going to leave that alone. Put that to one side. Over here, I have the green and red wire twisted under the red power wire. I have the shrink wrap tubing that's a little bit bigger than the other one in place. I've already twisted the wire. So now I put the butt end connector in there and twist it as I push it down. Make sure it's seated, and then I crimp it. And I crimp it again. And then I pull. See, that's why I test it. Something went wrong with my second crimp, and that came right off. So I'm hoping I can uncrimp the first crimp by squeezing opposite of where it was squeezed before and make that tube come apart inside. If I can't, I'll have to cut the wire and try again. Slippery stuff. Got it. Okay, so this tubing I'm going to cut in half so it doesn't get used again accidentally. There we go. Well, I still have one end, the other end went off somewhere. And I'll try it again. Luckily, I have more of these than I ever use in a lifetime. twist it into place. Looking through the translucent tubing to make sure I have it seated as far as it can go, and I do. It can't go more than halfway into the metal tubing inside this plastic. There's a small dimple that keeps it from going any further, so I can't go too far. And here I will crimp again, re-crimp. Extra good this time. And then I will pull harder than I did first time. And then I'll try this again.
Do you need a... You don't need a sleeve on that?
It's already on it.
Okay, just
Thank
checking.
you. Yep, appreciates it. There. That's in place. I'll take a look. Yep. Now, if the crimp was not done as well as it should have been, now is the time to find out, like I just did, so I can have a chance to redo it and make sure it's rock solid before I move on to other stuff. Okay, that feels good. So now I'll go ahead and hit this translucent blue plastic with heat. And after that is done and cools off, I'll put this other shrink wrap tube up here and shrink that down next. Well, it gets hot in a hurry, let me tell you. Make it away from anything that might get damaged with heat. Slide this up into place. And then hit that with the heat. Yow. Hot air. Okay, that one is done. So while that's cooling off, the outside it's still hot. I gotta move this gun out of the way. Like I had before, down on the ground away from me. Okay, it's all looking pretty good. Still hot. Too hot to handle. When it's done cooling off, I'm going to put this wiring back inside its black conduit. And then I have a short conduit somewhere where this gets plugged in to the spade terminal. Oh, it's right here. I plug it in, and then I can plug this unit into the alternator, plug this into the alternator, and then connect this and the double wired fusible link all bolted onto the alternator or plugged into the alternator. And I'll have Linda come over here and show some detail as I'm doing that. So come on over.
Want me to cut? Go.
Okay, so I have my left hand, the 3-wire plug that goes into the alternator. Here is the schematic I was following. Now I should point out that the charging system most people have of the 1971, 72, or 73 Mustang is not quite the same as the one we have. We had something called a side terminal alternator, where the white and black wire for the stator and the orange and blue striped wire for the field circuit went into a T-shaped connector that plugged into the side of the alternator, and the black and orange striped wire, which goes to the starter relay battery terminal, went on the side also. Most folks have this battery wire going to the back of the alternator to the large terminal, and then they have a black and white and black wire and an orange and blue wire going to little circular connectors that press onto the back of the alternator. The shape of the connector, although it's different, doesn't change anything electrically from what it is I need to do with the rewiring for this car. The first thing I need to do is make sure I can use this old wiring harness with the new PA Performance switch, which replaces the old regulator. Now I know where these wires go with the old regulator plug, which is plugged into the PA Performance switching unit. What I need to do is double check this white and black striped wire. And the reason is that circuit 904 is a green wire with a red stripe that comes off of the regulator harness. Later, it connects to this white with black stripe. Well, the white with black stripe is no longer going to be going to the regulator. It is going to be going to switch battery power. What I need to do is make sure that this white wire with the black stripe is not going anywhere else on the car, either a ground or a positive circuit. So the way I'm going to test that is I'm going to do a resistance test. And for that, I'm using a handheld digital volt ohm meter. I set this for ohms or resistance, and right now it says OL, which means out of limit. And what that means is that there's no connection between these two probes right now, which is correct. Now, if I were to take these 2 probes and touch them to the same conductive material, you'll see that it changes and shows how much resistance there is, and it also beeps to tell me there's continuity. So I don't have to plug in the battery for this. What I'm going to do is go to the back side. I take this safety cover off first. Who cares about safety, right? And I'm going to do what's called back probing, which is pushing this pointed probe into this white wire with a black stripe where it goes into this one terminal. And the reason I'm going to do that is so that if I find something that causes it to connect, it'll let me know, like right there. So now I'm going to hit the body of the car, and I should have nothing, and I have nothing. And I hit the positive battery post, and I should have nothing, and I have nothing. The reason I have nothing is that years ago, this white and black wire that connects to the green and red wire on the voltage regulator was once connected to the original carburetor electric choke. Well, I took that out of circuit and I replaced that wire with a positive 12 volts switched through a relay. So I took the white and black wire completely out of circuit. But what I have to make sure of now is that when I connect things up with a new regulator or new switching system and alternator, that I'm going to put in switch power to what used to be the white and black wire that connects to circuit 904 at the regulator, and make sure that that power doesn't go anywhere other than where it's supposed to go. In your case, if you are using an original electric choke with a white and black wire, you can still do that because full battery power is going to work just fine. It's a bit more than what Ford wanted to use, but it doesn't mean it's going to hurt anything. If you have an aftermarket carburetor using that white wire with black stripe, you've been getting inadequate voltage. The changes we're about to make for the alternator charging system circuit, it's going to give you full battery voltage like you're supposed to have with your aftermarket electric choke. Boy, that's a lot to say. I really hope I didn't confuse anybody or lose anybody and all that. Now, the other thing I need to do is take this orange and light blue stripe wire and connect it to the new voltage regulator socket with what had been orange and blue wire also, I think. I'm going to take a look at the schematic to make sure. But in the meantime, I don't need to use this square anymore, this T-shaped connector. So I'm going to be cutting these wires and stripping them because I bring them into a new circuit. So come down here, cut one. Boy, this is point of no return. I'm going to save this. I never know if I might need one later. Then I'm going to strip both of these. One stripped. Stripped. Okay. Now on my schematic that I showed earlier on my iPad, I'll bring it up again in a few moments. You'll see that on that schematic, it talks about a green wire with a red stripe coming off of the voltage regulator that then gets switched 12 volt power from the ignition switch. That's correct, but what they left out is that circuit 4, white and black, get spliced into circuit 904, the green and red, elsewhere in the car. So I can apply 12 volts of switch power to this wire and it will do what I want it and need it to do. I'd rather do that than get brand new wire and run it when I have a perfectly good wire right here. So earlier in the video, I found where I had 12 volts of switch power coming off of my windshield wiper. I had a segment of wire that had a spade terminal and a butt end connector. And so I've got this power wire here, and I need to connect red wire to the white wire with black stripe. And then that gets connected into this butt end connector so they both get power. So that's the first thing I'm going to do. I have to strip this other wire before I get too far. Oh, thank you. I looked down there and saw the edge and all that and got confused. So here's this.
In front of you.
I'm glad you're watching.
Do you want a slip sleeve?
Yeah, after I twist this. Linda is making sure I don't screw things up. I need to get, I can put that on up here and slide it down.
Okay.
So I take the power wire from switch 12 volt power, twist it into the white wire with a black stripe. Then I run this butt end connector over it while twisting it. Okay, so it's all the way down. Now I'm going to crimp it. Crimp it again. I'm crimping in two different spots right next to each other just to make sure that it's really crimped well. Because if anything goes wrong with this crimp, the charging system will not work properly. That's on nice and tight. So now, what I'll do is apply hot air here and here, as I re-terminated a new piece of wire with the spade terminal to make sure it carried enough current for the job that is ahead of it. And here's the hot air gun. Here we go. Then down here, I'm going to let that cool off for a few moments. If I try to put this heat shrink tubing down while it's still hot from what I just did, this will shrink down too soon and won't do the job I want it to do. And that's not going to be any good. So in a few moments I'll check it and see if it's cooled off enough. That one has, it's still warm. And that one has. Okay. So now I'll send down the larger tubing and then I will shrink that down. And while that's cooling off, I'll put the other shrink wrap tube at the other end. And then heat it up. Doesn't get much better than that. So circuit 904, which splices in with circuit 4, is now in circuit with switch battery power. But I still have to plug this back in so that power gets to my ignition module also. Otherwise the car will crank but won't start. I don't want that. See if that's cool, yeah. Yeah, hot. This is still warm, but it's cool enough to work with. Now, just as a reminder, I do have my battery disconnected at the negative terminal, so I'm able to work with all this stuff without worrying about causing a short circuit or anything else. But I'm going to start wiring in the orange and black wire from the alternator circuit that goes to the positive post of the starter relay, which connects directly to the battery. So I'm going to put this in place now and get things ready to start connecting up that terminal. Now, the other piece of that is to take the new battery wiring that I fabricated previously, where I got 2 lengths of fusible wire circuit, fusible link. This single wire eyelet ends up connecting to the battery positive terminal. These 2 ends end up connecting to the alternator output, just like my black wire with the orange stripe is that I just connected a moment ago. And then, okay, I don't know if Linda can come over here and get a look at this. But down where my left finger is pointing, that is the power outlet for the alternator, where I have these 3 eyelet terminal ends on right now. So now I'm going to put the lock washer on and the nut and then tighten that down.
Washers here, the nuts here, sure. You know those.
I wonder where's popped off. Oh, they both popped off. 3 popped off. Well, I'm going to keep this going, even though I'm having some trouble here, because I just want anyone watching this to see that it is entirely possible you too have problems doing this, especially it's one hand holding the light and the other hand trying to hold the wires in place.
Want me to hold the light?
Not yet. I might give up in a while, but I'm not going to give up quite yet. That gives me a lot of room for terminals, but I'm going to put these on first. They're not quite as rigid as this big black and orange one. That's real rigid. You know, I might end up doing is taking these 2 wires here and put them on a single terminal, because that's making it too thick. All 3 of them together.
I wondered why you did it too.
Well, I was trying to keep it separate, just keep it separate. I'm putting the nut and the lock washer back in the magnetic tray.
Good idea.
So it's less likely that they'll fall. And I'm going to cut these fusible links ends, and I'm going to connect them at the other end with a single eyelet like this, except smaller diameter, so it fits the alternator better. I could have done that before and I didn't. I probably have a reason for it, but now I see putting these 2 eye connectors on plus the large one is not leaving enough of the output bolt to put on the lock washer and the nut to tighten it down. So I've got to fix that. The way to fix it is connect these to a single eyelet at the alternator ends of the link.
Okay, gonna cut.
Yeah. Okay, here I've stripped the insulation from both ends, and now I'm going to intersperse these wires together and twist them together before I put my eyelet terminal on. And here I have twisted the wires together after running the 2 ends strands together. I twisted them nice and tight. And here I have a terminal end with a round eyelet for its connection, and I made sure that hole is big enough to fit over the stud on the starter motor relay terminal. So I'm going to take and twist this down on the bare wire, and once that's done, I'll crimp it in place. And here I have twisted the wires together, put the terminal end down over the wires after twisting them together. I put the heat shrink tubing on the wiring, and now that this is pushed in place and I crimped it, re-crimped again and pulled on it, it's not coming off. Now I'm going to hit this with the hot air and shrink the yellow translucent plastic down, and then I will put this red heat shrink tubing in place and shrink it down in place also. Now here I have hit the hot air on the shrink wrap installation that came with the terminal, And if you take a look at the ends, you'll see that there's a little bit of the copper wire peeking through the end of where they got crimped. This is why I like to put my own shrink wrap tubing on these. I want that covered, and so the shrink wrap tubing, when I put it in place and hit it, the glue inside that tubing will melt. It'll adhere to the metal eyelet. It'll shrink down, and when it dries, it will be a waterproof seal at both that end and back in here. And this is how I'm going to start the position of that shrink wrap tube. Down near the bottom of that open hole, we have a little bit of that overlapping. When it gets shrunk down, it's going to shrink down back toward where that crimp location is, and it will end up sealing that, but it won't be blocking that hole. Now, when you take a look at the shrink wrap tubing on both ends, there is one area where water could possibly enter, and that is in those little areas between those two gray fusible link wires on either side of that. So I can seal that with silicone, or even better yet, I have an ultraviolet sensitive glue resin that is thin, almost like water. I can put down there, and when it's in place, I can hit it with ultraviolet light. And when I do that, the resin hardens up, and it will seal rubber, metal, plastic, all kinds of things, and it will be sealed and adhered within 15 seconds of having ultraviolet light being applied to it. So I'm going to do that to both ends of this, just to make really sure I have it as waterproof as possible. And like I said, even though I started up a little higher in that piece of metal, it shrank down, but you can see some evidence of that liquid adhesive from inside the tube that is on that metal, and it's all the way inside that tube. Anywhere it touches, it is sealed. This is the ultraviolet resin bottle, and over here is the ultraviolet light. The way this light works is I hit the button at one end, and you have ultraviolet out here, and wherever we put that ultraviolet resin, we simply shine the light on there 10 to 15 seconds, and it causes the resin to cure. Now I put a few small drops of resin into those areas, and now I'm going to hit it with ultraviolet light. Okay, this is the shrink wrap tubing on top of the terminal that I wanted to put on the alternator. Its end is a little smaller diameter than the end going on the starter relay. And so I get those side by side. There, maybe now you can see the difference in diameter on the ends of the terminals. The one on the right is going to go on the alternator output terminal stud. The one to the left is going to go on the starter relay large positive stud that then connects to the positive battery through a cable. Okay, here are the completed ends for the fusible link that I put together. You can see that the red shrink wrap tubing has sealed down on the metal eyelets very nicely, and you see some shininess down there at the bottom where the gray wire goes in. That is the ultraviolet resin that I applied and then used ultraviolet light to cure the resin. Inside adhesive, bonding to the metal and to the rubber insulation. And we have the ultraviolet resin sealing the bottom from any water intrusion as well. So I don't think they can get much better than that, not for backyard work.